Hello all and welcome to this little kind of tutorial how to do specific problems relating to your study guide. I'm not going to go through every single problem, but I want to give you an idea of sort of how to solve particular problems and to set them up. So today we're going to talk about significant figures, scientific notation, adding, subtracting decimals, multiplying decimals, and then we're going to do some of those conversions. So to start off with, I want to talk about significant figures. And when we discuss significant figures, there are certain ways that we're going to look at this. So for instance, if you were to look at 4.35 or 435, these both have three significant figures. So pretty straightforward because they're all integers, there's no zeros, there's really no difficulty here. Same thing if I wrote like this, 4.35 times 10 to the third power, hypothetically. This would also have three significant figures. But it gets a little bit trickier when we start dealing with zeros. So let's go ahead and talk about what happens when you deal with zeros. There are three types of zeros. There is the leading zero. There is the captive zero. And then there are the trailing zeros. And when we discuss this, it gets a little bit tricky. So to start off with, again, we deal with leading zeros. Leading zeros will never count. So this is three significant figures. This guy here is a captive zero. So captive zeros always count. So this would be four significant figures. And when it comes to trailing zeros, this is when it gets a little bit iffy. And you have to see if there is a decimal place present. So again, because this is a leading zero, this does not count. A leading zero means it comes before an integer. So it won't count. But because there is this decimal place present, this zero will count. So 1, 2, 3, 4, 5. 5 significant figures are present. Now down here, because there is no decimal place present anywhere, this guy does not count. So this would only be 4 significant figures. And so sometimes people will ask, does it matter where the decimal place is? Like, let's just say hypothetically, I had this, or if I had this. Nope, doesn't matter. Those, because of the fact that there's a decimal place present, both of those trailing zeros will count. But if there's no decimal place present, then again, those trailing zeros cannot count. So I hope that makes a little bit more sense discussing significant figures. And rule of thumb is when you go to look at a problem, whatever number they give you, so let's just say hypothetically, you're starting with 4.00 moles. That's three significant figures because it's 4.00. So your answer should be written as such. It should be written with three significant figures. And so sometimes that's relatively very easy. However, sometimes we do have to use scientific notation, especially if we're dealing with an extremely small number or a very, very big number. And so when we write scientific notation, it should be written as one integer before the decimal place, and then however many numbers are present after. So let's just say hypothetically, we were dealing with this, 125. We would write this as 1.25 times 10 to the second power, because that second power is actually like saying that this is 100. Same thing if we had this. We would write it as 1.352 times 10 to the third power, because that 10 to the third is basically like writing 1,000. So you always want to make sure that your number is going to be one integer before the decimal place, not a zero, like a whole integer. And then again, you can write your numbers after, and then again, you'll put this in scientific notation to basically have it be equivocally the same. Now, let's just say hypothetically something happens here. So let's go back to this 125 times 10 to the second power. Let's say hypothetically I had it written like this. to the first power. So this is not in scientific notation. So what I'm going to have to do is I'm going to have to move my decimal place one place over to the left. And because I'm doing that, it's not like really just moving one place. You're actually moving up a whole power. So now this is going to be increasing by 1 power. On the flip side, if I wrote this times 10 to the 0 power, or actually, let me write it like this, times 10 to the 3rd power. Again, this is not in scientific notation either. So I want to move this to the right, and I'm going to move this down 1. And that will be written in proper scientific notation. So technically, this is not correct scientific notation, and this is not correct scientific notation. This one is. So if you have to move your decimal place to the left, you're moving up a power. If you have to move your decimal place to the right, you're going to move down a power. So I hope that makes a little bit more sense when you go to write some of these pieces. Now let's talk about when you add and subtract, as well as multiply and divide. So let's just say you have this number here. Okay, so we're going to add these pieces together. So more than likely you're throwing this in your calculator, but I'm going to show you how to do it without the calculator. So that way this makes a little bit more sense. So what I like to do is I like to look at my one with the greatest amount of decimal places, and I'm going to add zeros to sort of be a placeholder, if you will. So this is 3, this is 4, this is 6, 7, 1. So I end up with 17.643. Now, what I want to do is I want to go with the least amount of decimal places. So up here, I had the least amount of decimal places. So my number will be 17.6. However, let's just say hypothetically this number was a 7. I would have to round to 17.7, but because this number is less than 5, my number would be 17.6. Now, let's go ahead and look at it from a subtraction format. 15.85 minus 7.248, something like this. Again, same thing. I'm going to throw a placeholder in there, make my life a little bit easier. And again, this would be 4, 2, 0, 6, 8. So I end up with 8.602. Now, again, because of the fact that I only had 2 decimal places behind this one, I want to go with 2 decimal places behind this one as well. This one, we don't go with significant figures. We go with the least amount of decimal places. So our answer would be 17.60. So I hope that makes a little bit more sense when you start to look at all those components. Okay, now let's do a multiplication problem. So if I did multiplication and I had 6.2 times, let's do 5.20. Again, when I total this up, I'm going to get 32.24. Now, when it comes to multiplication, I am going to look at significant figures. I'm not going to look at decimal places anymore. I'm going to look at significant figures. And again, I want to go with the one with the least amount of significant figures. So this one is 2 significant figures. This one is 3. I'm going to go with 2 significant figures. So my answer is going to be 32. And again, I could write this in scientific notation, but because the number is relatively pretty small, we'll just leave it with 32. Now, let's just say you have this gargantuan piece here. So let's say you have 6.81 times 7.82, and we're going to divide this by 9.32 times 10.125. Yeah, let's make this a little bit more crazy. Okay, so now we're going to do multiplication and we're going to do division. So when you go to plug this into your calculator, Be very careful that you use parentheses to do so. So we're going to do 6.812 multiplied by 7.82, close your parentheses, divide, another parenthesis, 9.32 times 10.125. Close that parentheses. And you're going to end up with 0.56450. We're going to take it out pretty far. Okay, so again, same idea. We want to go with the least amount of significant figures. So here, the least amount of significant figures would be 3. So here we have 3, here we have 3. We're going to want to go with 3. Now, technically, this does not count. This is a leading 0, so this doesn't have to count. So we're really only looking at these numbers here. Because this is greater than 5, this number is going to move up to 0.565. And again, if I wanted to put this into scientific notation, I could write it as 5.65 times 10 to the negative 1, and I could do it that way. But again, because this number is relatively small, I would just leave it in this format. So I hope these make a little bit more sense when it comes to multiplying and dividing, as well as adding and subtracting. So adding and subtracting, you go with the least amount of decimal places. Multiplication and division, we're going to go with the least amount of significant figures. All right, now why this becomes important is because we have to think about conversions. So when we discuss the idea of conversions, we are going to be thinking about, for chemistry purposes, SI units, standard international units. And so there's the English system, there's the metric system, and then there's the SI units. When we think about SI units, well, when we think about measuring distance, we think about measuring in miles. They think about measuring in meters for distance. When we think about volume, we tend to think about ounces or we think about gallons. But for SI units, they think about liters. When it comes to mass, we tend to think about things in pounds. Like when we think about weight, we think about pounds. They're going to think about grams. And when it comes to temperature, we love to think about things into degrees Fahrenheit. But for SI units, they're going to think about Kelvin. So that's a little bit different than the metric system. The metric system likes to use Celsius or degrees Celsius, but SI units are going to use Kelvin. So because of this, we have to understand how to convert back and forth with these units, because these units can have prefixes. You can hear about a kilometer, you can hear about a milligram or a centigram, or you may hear about a milliliter. And we have to understand those equivalents. So I'm going to show you a trick way to do this. If you are already comfortable with conversions and you understand like 1 kilometer is 1,000 meters, 1 nanometer is 10 to the negative 9 meters. If you're comfortable in those formats and just kind of memorizing that, completely fine. Go ahead and keep those relationships at hand. You will be asked to understand those relationships, but I do have a little trick way to know them in case you're not super comfortable. So we're going to write it out like this. And the way to remember this is that King Henry died unexpectedly drinking chocolate milk. Gap, gap, micro, gap, gap, nano. All right, so what this part does here is this discuss the unit. So again, when we think about the unit, we think about grams, we think about liters, we think about meters. K stands for kilo. This is hecta. This is deca. We have deci, centi, milli. Again, I do a little bit of a gap. They still are a placeholder, if you will. This is micro, placeholder, placeholder, nano. And so you can use this little format to convert back and forth. Let me show you an example really quickly. So let's just say hypothetically you had 2 centimeters and you wanted to convert this to millimeters. So you could know that there are 10 millimeters and 1 centimeter, that's fine. You can understand those relationships, or again, you could try to convert it to meters and then get it back to millimeters, whatever you want to do. The way I look at it is I say, okay, I have centi and I want to get to milli. So I'm going to move one place over to the right. So because of that, instead of having 2 centimeters, I'm now going to end up with 20 millimeters because I'm moving one place to the right. Now, let's say hypothetically I did the opposite. I went 2 centimeters and I want to figure out how many meters that gets me. Now I'm going to move 1, 2 places to the left. So I'm going to move 1, 2 places to the left. So I end up with 0.02 meters. And remember that unit is going to be your grams, your liters, and your meters. So I want to get to meters and I'm starting with centimeters. Let's give another example really quickly. So let's say you had 0.4 centiliters and you want to get to liters, just as an example. Okay, so let me write this in green really quickly. So again, same thing. I want to move 1, 2 places to the left. Or let me give you guys a different example because I feel like we already kind of did that one. Let's do this. Let's just say hypothetically you had 10,000 micrograms and you wanted to figure out how many kilograms that was. So let's give some pretty wonky, crazy number here. I'm starting with micro. I want to get to kilo. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So a pretty relatively small number when we start to think about that. Now, because of this number being so unbelievably small, we are probably going to end up writing this in proper scientific notation just because it is such a truthfully very, very small number. And it makes sense because micro is very, very small. So you need a lot of micrometers to make up a kilo or to make up a meter or a gram, whatever you're thinking about here. So let's give another example really quickly. Okay, so like I said, King Henry died unexpectedly drinking chocolate milk. Placeholder, 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 nano. Let's just say I had 5,000 nanometers. And I wanted to figure out how many micrometers were present. So nanometers are here. I'm going to move 1, 2, 3 places to the left. 1, 2, 3 places to the left. I'd end up with 5.000 micrometers. And I could flip it the other way. If I had that, I could say, if I wanted to go from micrometers to nanometers, I could just move 1, 2, 3 places to the right. So I hope this makes a little bit more sense. If you have any more questions about this, feel free to ask, but I think this could be definitely a little bit more helpful when you're trying to figure out these relationships. And remember, when you think about the unit, this is like saying 10 to the 3, 10 to the 2, 10 to the 1, 10 to the 0, which would be like just saying 1. 10 to the -1, 10 to the -2, 10 to the -3, and so on and so forth when you're trying to figure out those relationships. So for a kilogram, you have 1,000 grams. For 1 milligram, you have 1/1,000 grams when you're going to write these pieces out and try to make sense of this. All right, if you have any more questions about this, feel free to ask, but I want to move on to one other thing as well. Now, you are going to be asked to convert for temperature. And so for temperature, again, we like to think about things in degrees Fahrenheit. And you could be asked to put things in Kelvin, but we can't just go straight from Fahrenheit to Kelvin. you have to convert from Fahrenheit to degrees Celsius and then get to Kelvin. And so to do so, there is a proper equation that you can use for both Fahrenheit and Celsius to go back and forth. So if you want to figure out what degrees Celsius is, it is going to be degrees Fahrenheit minus 32. Oops, my thing got stuck, sorry. And again, in parentheses, divided by 1.8. So let's just say hypothetically, we know body temperature. Body temperature is 98.6. We can do 98.6 minus 32. Again, put this in parentheses and divide it by 1.8. And that'll give us 37 degrees Celsius. Now, if I want to get to degrees Kelvin or Kelvin, all I have to do is add 273. Once I get from degrees Celsius to Kelvin, all you do is add 273. And if you were asked to go from Kelvin to Fahrenheit, again, you'd have to use these equations to go back and forth. So the equations to know are Fahrenheit minus 32 over 1.8 equals degrees Celsius. Or you can see that you have degrees Celsius times 1.8 plus 32. And where I'm showing you the parentheses, be careful to utilize these in your calculator. Otherwise, you'll get some very wonky numbers. And this equals degrees Fahrenheit. And like I said, if you're working in a specific manner, this is the way you have to go. You can't just go straight from Fahrenheit to Kelvin or Kelvin to Fahrenheit. You would have to go to degrees Celsius first in order to make this happen. All right, so I hope that makes a little bit more sense. That's kind of my first little bit for you guys. So we went over scientific notation, significant figures, addition, multiplication, subtraction of decimals. We talked about the conversion sort of pieces and again, converting temperature. So that's my part 1 video. I hope that makes pretty decent sense. And I hope you guys are having a wonderful day. Bye guys.